Okay, so last class we did just simple questions on solving circuit analysis. I'm going to review that one more time and then we will go to a complex one. This is a very simple one. And R1, R2, and R3 is connected in series. The first thing we do, we need to find the total resistance of the system. So the resistance is in series, so you just to add them, right? So our total is going to be R1 plus R2 plus R3. So simply R1 is 10 plus 20 plus 30. It's going to be 60 ohm, right? This is going to be 60 ohm. The next step is that I see these three column. Two of them is here, just one missing. So we used V is equal to Ri simply because two of them we can find the third one. What is missing is current, right? So current is equal to V over R. So current is V, voltage is 6 here, and resistance here is 60. It's going to be 1 over 10, which is 0.1. So 0.1. Also, I know the current passing through one path, or if this is series, the current passing through all of that going to be the same. The current passing through 1, 2, 3 going to be the same as the total current. That was the law. Now I see these three things, right? One is missing, so definitely I can use V is equal to Ri. Here I'm solving for voltage, right? V. So V is equal to R. R is 10 multiplied by I, 0.1, give you 1. Again, V is by R, right? 0.1 or 20 multiplied by 0.1. 20 multiplied by 0.1 is 2. And here V is 30 multiplied by 0.1. It's 3, right? This is 2, this is 3. The answer for voltage is going to be 1, 2, and 3, and that's it. That was a simple example for a series, simple example for parallel. We have a resistance. The first thing we do, we need to find a total resistance. 1 over R total is 1 over 10 plus 1 over 20 plus 1 over 30. Common denominator is 60, means this should be multiplied by 3. This need to be multiplied by, multiplied by 6. It's multiplied by 3. This is multiplied by 2. If I do it, it's going to be 6 plus 3 plus 2 would be 11 over 60. 11 over 60, right? But I need to find RT. I need to flip it 60 over 11. Now, that would be 5.5. Okay, so total resistance is 5.5. I need to find the current. So look at that. I have three things. One is missing, so definitely V is equal to Ri. I'm looking for I, which is V over R. What is the V is 6, R is 5.5. If we do it, look at it. So I'll just skip to that. It's 5.5. And now the current will, of course, going to be different here, but the voltage across the battery should be the same as the voltage across all of these loads, correct? Because this is the parallel, right? So what I do, the voltage here is going to be 6 everywhere. Now I need to find current here. So again, V is equal to Ri. I'm looking for current. V over R. I is going to be V is 6 over 10. It's going to be 0.6. Here I going to be 6 over 20 is 0.3. And I is 6 over 30, 0.2. So 0.6, 0.3, and 0.2. Okay, simple. Now we're going to more complex one when we have a two parallel, and this two parallel, it's kind of in series with that one. Now, how do we tackle that? First things you do to find a total resistance. Okay, how do we do that? So I see that immediately these two are in pair, no doubt. If this end is connected to this end of that without any interruption, right? You can go through this path. So these are the same point. And this end can be connected to the other end here without any interruption. So for sure, these two are in parallel. I know 1 over r 2, 3. Going to be 1 over r2 plus 1 over r3. So here is r2. R2 is 20. R3 is 30. So common denominator going to be 60. This multiplied by 3. This multiplied by 2. It's going to be 5 over 60. So I need to flip it to find R23, right? It's going to be 60 over 5. It's going to be 12. It's going to be 12 ohms. So, sorry. I can replace these 12 ohm by 12 ohm. So, my circuit will be look like that. So this is my R1. And now I just replace the total things by this R23. And this is what I have. So this is R23 and here is R1, right? R23 is 12 ohm. Now look at that. These two are after each other. So successively after each other means they are in series. So this is 10. To find out our total is just simply 10 plus 12, which is 22 ohm. So now I got my R total, which is 22 ohm. Okay. Now I have three things. I can three things. Two of them is known. I can find the third one. So V is equal to Ri. I need to find I. So V, which is 20 V. Okay, let me just write it down. V over R. So here I is going to be YV is 6 over 22 divided by 2 is 3 divided by 2 is 11. So it's kind of roughly 2.5. I'm going to keep it as 3 over 11 here, right? Now, I need to figure out the rest. Okay, how do I do that? These are the steps. Now, here is, I can't find the voltage across R1. How? Because voltage is Ri, right? Do I have I? Of course I have, because this I coming, the total I gonna be the I passing through this. I got it. The total I 3 over 11 is passing through this one, the same thing. So, and I do have R1. My R1 is 10. So 10 multiplied by the current is 3 over 11. It's going to be 30 over 11. So I have this R1, the V of that, see, which is 30 over 11. Now, simply from that, the current, I'm going to really replace it by 3 over 11, right? I just told that the current passing through R1, I know that. Now, I know the voltage across this one gonna be 30 over 11. Maybe I just write down. V1 here is gonna be 30 over 11. How do I find this V23? So that's my question. Since I know the voltage of the battery, what is it? The voltage of the battery is the total voltage. It's going to be 6, right? V of the battery is 6, and you know that the voltage provided by battery is the same is equal to the voltage across these loads. So V battery is equal to V1 plus V23. So V battery is 6, V1 I know is 30 over 11, and plus V23. Okay, so just rearranging for V23 is equals to 6 minus 30 over 10. So it's going to be, over 11. So 66 minus 30, going to be 36 over 11. So I got the V23 to be, I'm going to use a different color here. V23, I got it to be 36/11. So the total V here, if you put voltmeter there, this is gonna be 36. So the total V is going to be the same V across R2 and the same V across R3. Why? Because this point and this point are the same. See, they can connect it without any interruption. This point and this point are the same, connected without interruption. So again, this one and this point are going to be the same, connected without interruption. And this point and this point are the same again. Again, connected without interruption. So I can say that since these two are in parallel, the total V and the individual V on R2 and R are the same. So now my problem is solved. This one going to be 36/11, and this one going to be 36/11. Now the question is current, so it's easy because again, V is equal to, using different color, V is equal to Ri, and I'm looking for current. Current is V over R, so I'm just using that here. So I is V, which is 36/11, need to be divided by what? R, which is 20. So I'm going to do a little calculation. 36 divided by 2 is 18, divided by 2 is 10. So it's 9/55. Here is 9/55. Okay. And here I need to do the same thing. I here is equal to V over R. V is 36/11, then divided by 30. Divided by 3 is 10, divided by 3 is 12, divided by 2 is 6, divided by 2 is 5, right? It's going to be 6/55. See that? 6/55. Now, I'm going to check my currents because the current coming, using different color, the current is coming, right? And it's going to the two different branches, means incoming one, which is the I total should be equal to I, that is going from 2 to the 2, right? Plus the I3. I can check that. So I total, which is 3/11, and I2 is 9/55, and I3 is 6/55. If you add them, do this right side and the left side are the same. Let's do that. They have the same denominator, just add them up. It's 15/55. I can simplify. Divide by 3 is gonna be divided by 5 is gonna be 3. Divided by 5 is gonna be 11. Yeah, the right side and left side are the same. So check mark. I got it. Again, incoming one should be the same as the outgoing into the branches. And that's about this examples. I'm going to do another example on the worksheet. Maybe the first worksheet example is going to be, right, this one's the solution, I guess. I'm going to quickly go through this, which is very similar to what we did. Okay, and these are the questions that the student need to do as homework. Probably you will get that one in a quest. Again, you have to replace the parallel one because we want to find the R total, right? The first step is to find the R total. Let's see if I can do that quickly. Right. Here, V total is the V of the battery, which is 100. Just immediately put that there. And here, next step is to find R total. I know these two are in parallel. So R1 over R23 is 1 over 1500 plus 1 or 1500. It gives you 2 over 1500. I need to flip that to find R23, right? Would be 1500 divided by 2. Gonna be 750. So the R total here gonna be 700. If I just replace the whole thing by 750, now R1 and I call it R23. R23 and R40 are in series, right? Connected in series. Therefore, R total is just simply 100 plus 150 plus 750 is equal to 900, so it's going to be 1,000. Okay? It's going to be 1,000, so our total going to be 1,000. Now, can I find the I total? Of course, because the V is equal to RI. I is V over R. V is 100. R is 1,000. It's going to be 0.1. So here I going to be 0.1. Now, interestingly, I coming through the total coming through the from battery going to be the same as I passing through R1, right? So means I1, I get I1 as well, right? I1 going to be the same as I total. It's going to be 0.1. When this I coming here, it will be going through this, become I3, come here, it become I2, and then again, when it's going back here, addition of that, this will be I total, right? So then I total that passing through R4 going to be the same. Because this is now either that going through the battery, right? Because again, this outgoing would be addition of the I2 and I3. So that would be the same as I4. So I4 going to be 0.1 as well. I just need to figure out I2 and I3. So looking at this picture, I'm going to just erase something maybe. Looking at this picture, I can find the voltage across here. Why? Because do I have R? Yes. Do I have I? Yes. Actually, I need to just fill in this blank here. R1 is going to be 100. R2, we have 1500 here. R3 is again 1500 again. R4 is 150. As now I see better. I have two things. I can find third one. Again, V is equal to Ri. So I'm looking for V. V is equal to R multiplied by I. So 100 multiplied by 0.1. If you do that, it's going to be 10. So that would be 10. Now here I can find V. So V again is Ri. So 0.1 multiplied by 150 is going to be 15. Going to be 15. Now, how does it help me? Because I know the total V across the R2 and R3 going to be the same because they are in parallel, right? The V across the whole thing here are going to be the same. We just have one V here. We call it V23. Okay, so, and I know that these R1 are V1, V4, and V23, they are in series, right? So then V of the battery should be equal to V1 plus V23 plus what? V4. I have V of battery, which is 100. V1, I got it to be 10. V2, 3, I don't know. V4 is 15. Is 15, right? Is that the V total is 100? Right. So here going to be 25. 25 minus 100. V2, 3. Going to be 75. So the total V going to be 75. I know the individual V going to be the same as the total V because they are in parallel. So that would be giving me V2 to be 75 and V3 to be 75. Now it's easy to find I because two things is given. I can find a third one just using the V is equal to Ri, right? Again, V is equal to Ri. I'm looking for I. I is V over R. Here, V is 75 over 1500. Okay, so it's going to be 3. It's going to be 100, so it's going to be 0.03. Okay, so that would be 0.4 I2 0.03. The same thing here because now V over R, right? So it's going to be 0.03. Does that make sense? Um, did I do it right? I just need to double check my eyes. So the I total coming should be the same as I3 plus I2. And perhaps they're gonna have the same, they will have the same magnitude, right? Actually, I made a mistake here. I think I need to redo that. So 75 divided by 15. I think that would be um, sorry, it's just 15 here is 75. Let me just do that again. It's yeah, I made a mistake here in divisions. I need to um, revise my work here. Um, okay, I'm gonna just erase that. That was a mistake. Okay, let's just do that one more time. Again, V is 75, 1500. Okay, divided by 5 is 300. Divided by 5 is 15, right? Divided by 3 is 5. Divided by 3 is 100. Divided by 5 is 1. Actually, let's just do that. It's going to be 0.05, okay? Makes sense? 0.05. That would be the same thing here. Now it makes sense. Why it makes sense? The reason is the I coming, it's I total, right? This is the coming, I total is coming here. And it will be I total going to be I3 plus I2. I total is I3 plus I2. So I know I total is 0.1 is going to be the same as 0.05 plus 0.05. Yes, if you add them, it's going to be 0.1. So it's check mark, right? They are the same. This right side and left side are the same. So we did the right things. So things that you can at the end when you do find your answers, you can check it out. Okay, so the student need to follow the same rule to solve this question. So you will get one complex example for your test and two simple ones, as I did before.